So this is a conservation of energy question, and it also links to the conservation of momentum. Now what we have here is a sphere that's attached to a fixed point here, and it's released from rest, and it can fall down. It strikes this block and the block moves off. Now we're given a few bits and pieces here. We're given that this block here is going to fall a distance. The sphere falls a distance of 1 meter. Now we're going to be using a few equations for this question. So we're asked to find the velocity of this block after the collision. So the velocity of the block after the collision. Now the first thing you want to remember, or just maybe list off the important equations. Well, we know that the potential energy is given by mass times gravity times the height. We know the kinetic energy is equal to 1/2 mv squared as well. Now, what we need to know from this question is we need to find the velocity after the collision. Now, whenever you see the word collision, you also want to be thinking about the conservation of momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So these are the 3 different equations that we're going to be using for this problem. Now, first things first, we calculate the loss in potential energy that this sphere will go through. Now we know its mass, we know gravity is going to be 9.81, and we know the height it falls through. So the lost potential energy is equal to, let's write mgh. In our case, it's the mass is 10, gravity is 9.8, and then the height is 1 meter. If you multiply these, you get 98 joules of energy lost. Now, that's equal to the gain in kinetic energy. Kinetic energy. Now you remember the kinetic energy is 1/2 mv squared. So I know that 98 joules is equal to 1/2 mv squared. Now I can fill in m as well, and we can work out the velocity of the ball when it gets there. So it's 10. So 98 is equal to 5v squared. V squared is 98 divided by 5. Well, 5 into 9 goes once, 4 left over. 5 into 48 goes 9. 3 left over. 5 into 30 would go 6. And V will be equal to the square root 19.6. I'll just get that out quickly. And I've got square root sign there. 19.6 is equal to, change, 4.4, and I'll round up because this is bigger than 5, 4.43. So V is equal to 4.43 meters per second. Now we've got its velocity. Now I can work with this formula here. Now, one thing to notice about this is that, I must move that over there, is that for this here, it's called the sphere M1 U2. So the sphere is M1 U1 plus M2 U2. I'll just write out the equation first. M1 V1 plus M2 V2. Now I'll highlight in yellow the sphere. That's the sphere. And I'll highlight in blue the block. That'll be the block, the second mass. Now the block isn't moving before the collision. U2 is equal to 0. So I don't need that part of it there. Also, the sphere isn't moving after the collision, so V1 is equal to 0. So I don't need that part. So this breaks down to a really easy equation. M1 U1 initial velocity of the sphere times just before the collision now times the mass is equal to m2 v2. And I can sub in my numbers now. I know the mass of the sphere was 10, its initial velocity was 4.43, mass of the block is 15 kilograms, and then this is the velocity that we were asked to work out. So we'll just leave it as v2, or we'll just leave it as v. It's the velocity we want to find out. So divide both sides by 15, and I get v is equal to 10 divided by 4.43 divided by 15. Again, if I quickly go to the calculator, multiply this by 10, previous answer, and then divide by 15. I get an answer like this here, but just to rearrange it, I get a velocity equal to 2.95 meters per second. So this here is a good example of using the three important equations that we've looked at: potential energy, kinetic energy. This uses the conservation of energy, which is that the lost potential energy of the gain in kinetic energy, and then we have the collision, so we use the conservation of momentum, and that's what it breaks down to. So that's a good example to be able to do.